All right, welcome ladies and gentlemen to week number 36. This is Open Q&A. My name is Brian McLogan and thank you so much for joining me tonight for my live stream, which I want to cover a couple quick things on grading and some of the things that I handle inside my classroom regarding zeros. And then I will get to your guys' questions that have been submitted using the Google form that is down in the description. So if this is your first live stream, with myself, then feel free every Sunday night at 9 p.m. Eastern Standard Time. I go through your questions that you are having inside of your own math class. So welcome, Isaac, Gaming Wizard, Peak Plays, the Black Stormer. Thank you so much, guys, for joining in. I will be getting to your questions, but I know I also wanted to handle some of the ideas that has kind of come up regarding grading, and it's really been. There was a couple articles last couple weeks or last couple years I remember seeing about, zero sum grading, and there was all these conversations that were going back and forth as far as like, is it good? Is it bad? And I remember I was thinking about making a video on that topic, and it was something that I really just wanted to kind of like try and think about, like, does this have any merits of not giving a student zero? Am I just giving them grades? For that, because I think anybody that goes down to the idea of just giving a student a grade for, not having any work or anything like that, you just immediately feel like you're just giving the student something for nothing, right? And I'm definitely, it's still kind of one of those things that's just like embedded, into kind of like the philosophy, like teaching philosophy, or just I don't know, normal philosophy going on and getting something for nothing. But, when I really looked into a lot of my grades that needed to be done, if I was giving students a zero because they didn't turn in homework, or if I gave them zero because they didn't show any work, or their problem was completely wrong, in the end, I looked at their grades, and typically those were the students at the end of the semester or at the quarter that I usually had to do something extra, either curving or give them like a retake assessment or, something to be able to redo those zeros. And I really just kind of thought to myself, it's like, is there maybe a better way? Even if you give them a curve, like at the end of the quarter, just to get them from a F to a D. What's the difference if you are just applying like a zero-based grading from on there? And so it's something I wanted to give a try, and I wanted to see really how my grades kind of changed. And to my astonishment, I will say that my grades really did not take a huge benefit. I thought that, if I'm just giving students so for instance, if I just give my students like a grade or not give them a zero, I was thinking all my kids are going to get A's and B's and, C's. And it's actually not the case. As many students that failed my class before still failed my class when I didn't give away zeros. The same amount of students that got A's and B's and C's still got A's, B's, and C's. I think the difference though in the grades was the students that were on that cusp of, trying to get to that D, trying to get that C, trying to get to that F. They had much of an option. I didn't have grades that were like at 20%. If a kid failed, they failed, right? But instead of being at like a 25%, they were at a 52%, or something like that. And it really just gave those students an option, a choice, or not an option choice, but an opportunity that if they wanted to put in the work and the effort to pass my class, they could do it. Whereas, once you kind of give students those zeros and you keep on adding in that, you're not doing work, you're not doing anything, you don't know anything, which is kind of like the attached stigma, the students just shut down. They fail, they give up, they don't try anymore. And that's something I saw over and over and over again. And I wanted to, a lot of these students that maybe don't do something, it doesn't mean they're not understanding anything. It's either they forgot an assignment or they, maybe they were just stuck or they had a bad day or a week. And in the same respect, I think it also kind of comes in, what's the point of the grade? Are we really assessing them to have things turned in because we want to build that society of students turning something in for the next day? Or we're trying to, really give them a grade based on their understanding and, for what it is they know. And a lot of times when students are completing work, but maybe they don't have it turned in or they maybe don't show all the correct work, the zero just kind of leaves them no opportunity to be able to show by the end of the quarter that they understand something. So, in the end, it is kind of something that I know a lot of students or a lot of people are still like adamantly, against the zero-based grading. But I can definitely say that when I didn't do zero-based grading, I had to basically curve my grades to get a lot of those students at the lower end. I had to be able to apply significant curves. So basically those kids were getting, grades, because otherwise my grades would have been like almost everybody like fails or get D's and C's, like I had to apply a curve to be able to boost those grades, which is basically giving kids grades for free anyways. So by applying the zero-based grade, I didn't have to do that anymore. And it's really just kind of giving students a baseline that they can work from. And again, the students that fail still fail. The students that are going to get A's still get A's. I really have not seen much of a difference. There's only those students that are on the cusp. That's really where it made the change. And that's what I think is most beneficial, the reason why I like it. So let me just kind of explain a little bit the way that I do it, and then I'll kind of see if there's any questions before I get into the math from you guys. So the way that I apply it is there's two ways. So basically when I give an assignment, for instance, homework, every chapter or every section, we still have homework, and then, different assignments. If the student doesn't do the work, then I just excuse it. So it's basically, we cover a lecture, we're going to cover a topic, they're going to do it. But obviously if they do it, they get points for it. That's going to help their grade. If the student decides that they don't want to put in the effort to work, rather than giving them a 0 and punishing their grade for not completing an assignment, I just excuse it. And I just assume that they have some information that they're able to do. And they have the information, and, they just decide not to get the bonus credit for it. So it doesn't negatively impact their grade. The next way the next thing comes into the quizzes. And this is the one where I was really thinking that, man, I'm just going to give away all these A's and B's on quizzes. And so the funny thing is, so I give a quiz and I have 4 free response and 5 multiple choice. And it's just amazing the statistics that, how this works out, that rather than giving students a 0, like let's say they leave a problem blank, if they leave a problem blank, instead of giving them a 0, I just give them a 5. And basically all it does is it just changes my grading scale. Still giving them a 5 is failing. So they still failed. But rather than changing the scale from 0 to 100, it just changes the scale from, 50 to 100. And you would think that, oh my God, everybody's going to pass. There's no way they can fail that test. I have students fail and get D's and C's all the time. And really just the only difference is for my other grades, when I gave them 0s, I would just have to apply a curve. That literally the grades about the same. It's just, I don't have to apply a curve at the end or, drop their quiz grade because students are scoring, so poorly. So it really, I think, is a much more of a honest approach. And I know, when you think about it, oh, you're just giving kids points for nothing, on that approach, yeah, of course that seems unfair, but in the same respect, isn't applying a curve, giving points to students for no reason, kind of that same idea. And, that's exactly the way I think about it. And again, my grades have not been impacted. Are inflated, I would like to say, based on that. And the one thing though, because I guess the one thing where the zero-based grading does not play an effect is the multiple choice portion of the test. And I think that is where that kind of balances it a little bit with my courses or with my classes. So regarding, so they get that kind of buffer, that grading scale of really from a 5 to a 10 for all their free response. However, for the multiple choice, wrong is wrong. There's nothing else I can really do for you on that one. And, for those of you that know multiple choice, there's not a lot to like about multiple choice because you can make one simple mistake and then you get the whole problem wrong, right? But yeah, so yeah, technically if you got every problem wrong on a multiple choice test, there is no 50% that you're going to get. You could theoretically get a 0 out of 25. And maybe a student has got that once or twice in my class, but those have been pretty, definitely somebody that is just kind of showed up and needed to take a test and get a grade and, filled something out. But I would definitely say that grading and mixed in with the free response, averages out. And really with the homework, the students that are not turning in the work, again, most of my grades, the only difference is and I guess here's the thing is, students are still failing my class, as I mentioned to you. But the only difference is rather than having 20% and 15%, those students have 40% and 50%. And there are those students that just need, like, they're really, really close. They do know something. They're just, having trouble getting to the cusp. And rather than having a 30% and really should be passing my class, they have a 40, or 58%, and they should be passing my class. And then it's much easier to work with them to be able to get them over the edge. So, that's what I'm going to do it again this year. It's, I think it's something that's been really beneficial for the students. I think it is a fair way to approach their grading for them and for me. And it's something that as long as the students are, I don't tell them directly. So we'll see who's, on this live stream for my students, but, I don't tell them when they go on live, but, I don't tell them that. So it's not something they, I think, expect, or they feel like they're getting something free, but in the same respect, it's something that, I think they see with their grades, and they still have to work for the grades. I mean, they really do. They have to put in the effort, and they still complain that the course is hard, and they want more free grades. They want more extra credit. All this typical things are still there. So I see a lot of the people that, have trouble with the non-zero based grading. But I've just not been seeing a lot of those things come true in my classroom. So I'll leave it at that. I'll take any questions that you guys have. I'll kind of screen through the chat, kind of see if there's anything for there on you guys. And then, yeah, if you do have any thoughts or any questions, feel free to add them into the chat before I get into some math. I only have a couple math questions that I'm going to be able to do today. And the reason why is I did get submitted like five word problems. And I do apologize, guys. Tonight was not one of those days that I could show up, do the live stream, and get to word problems. It was a busy day. I'll just leave it at that. And so if you're aware, I'm maybe one of my on my email list, you might have received multiple emails from me. I apologize. I made a mistake, and I was trying to fix it. So just wanted to get that on the record there. But yeah, so I will go and cover that. Any other questions you guys may have or kind of see? Oh, Clancy, the man that got me throughout college. Well, happy to help you out. Clancy, thank you so much. Any tips for studying differential equations? I think the same tips for studying differential equations would be the tips for studying anything, which I'm going to get to actually at the end. There's another question just about like studying, like how to do, and this was like for algebra too, but I mean, it's going to be the same. And actually, I'm going to write them down. I always like writing them down. All right. Johnny V, I saw your question. And I don't understand your question. I'm not so much I don't understand your question. I didn't have time to really look through it, but it's not something that I'm familiar with. So I do apologize. Thank you so much for showing up again for the live stream. But it was something, again, one of those word problems I looked over. I'm like, this isn't something I would need to spend more time reviewing and like reading your question. So I do apologize. I'm not going to be able to get to it on the stream. All right. Can you talk about function translations? I can, Mike, and I have an extra slot actually. So good for you for typing that in. And I will actually discuss that for you. All right. Crest of 0 factorial. Mr. Wu actually has WooTube has a great video on 0 factorial equals 1, I believe, or Black Pen, Red Pen. I think he has a good video on that as well. So they will do much better justice than myself. But I would definitely check their videos out. Hey, Abrenum, let's see if there's any questions. Alexander Lee, here's your shout out, bud. There you go. Hi, Jonathan, Ethan, Eugene, Crunchy. I'm so sorry to hear about that. Yeah, I don't know. It's funny you guys think that the coaches or the teachers, I think my students feel a lot of the same things with stuff that I go through or that I'm teaching inside the classroom, as far as the pacing or not explaining something to them well. I think it's always helpful to a lot of you guys come to my channel or you come to the live streams to get some extra help, and I think it's always important to have somebody else that you can rely on and ask those questions to. because I see a lot of people, they have trouble like, I'm not understanding my teacher, or you explain things. And I'm like, oh yeah, of course, whenever somebody else has explained something or, can able just to teach something, it always helps out. And so I'd always recommend if you are struggling with whatever teacher you have this year or however things are going, I would definitely recommend getting somebody else or some other teacher that you can just kind of bounce that instruction off of. A true teacher does not terrorize ignorant students. A true teacher knows that his job is to cure ignorance. Who are you talking to? Okay, well, I guess there's no other questions on that, so I'll just keep on going down. You guys got trusted. All right, don't be getting the chat. My wife is on the phone. I can hear her in the other room, but I don't want to put you in a timeout. I can talk about the sum and difference of two cubes, but please be careful, by adding multiple things in the chat. All right. But I will take in your question just because I know that you had in good heart that that's what you wanted me to do. JT Super Gaming says, what level of math do you teach? This year, I am teaching Geometry Standard, Geometry Honors, Algebra 2 Honors, and Pre-Calculus. So yeah, it is crazy for on there. Equals BX. I'm not sure what you have for there. And guys, make sure you also get into your questions as you guys are getting questions. Remember, guys, I go live every Sunday evening from there. So I am happy to answer your questions. All you guys have to do is pre-submit, which I believe, if I am correct, I have my questions in the Google form as well as the Discord. And I know it's not always as great for you guys to go ahead and post questions in real time, but you can go ahead and always, post it in the Discord server as well, where you guys can talk about that. All right, so let's go ahead and I'll get to maybe some of your guys' questions here too. And I want to make sure I get to the questions that I had up here. Functions. Oh, translations. That's what I was going to talk about. All right, so I have functions, translations. I remember somebody was saying something. Yeah, do you think teachers? There's finally a question. Here we go. I'm taking honors geometry. Well, hey, Zivo. Actually, I'll talk about some new videos that I have up there coming. Do you think students should, or you think teachers should have credit for missing one question? I mean, it depends. I mean, it depends on what are you talking about the question. Like if it's a free response or a multiple choice, like I think it all depends. I mean, I'm not sure what for missing one question. Like I said, I literally, if a student doesn't turn anything in on the quiz, so here's the thing. If a student doesn't turn anything in on the quiz, they have a 50 out of 100. So it's still a failing grade, but rather than giving them a 0, it's just a 50 out of 100 F. So it just brings up that grading scale a little bit more. They still fail. And, but it just doesn't, have as negative of an impact on their grade. And like I said, the students that are getting if a student's leaving a whole quiz blank, they have some other issues in the course, right? It's not just like one quiz. So they have a lot of uphill to go through on other assignments as well. Junior, senior, high school math. That's awesome. And I'm here first year of grad school. Well, awesome. Thank you so much, Annie. That's awesome for you. What is the base of geometry? I'm not sure what you mean base of a figure. I'm not sure what you mean in geometry. Can you do a quick down on continuity? Man, you guys are bringing in a lot of questions. Hector, just continuity. That just means it is continuous, meaning that there's no breaks or holes in the graph. That is the basic definition that I can go through for you on that. And I want to say thanks. You are very welcome. All right, so let me just kind of go through a couple quick things here. So we talked about the zeros. I did want to let you guys know that if for those of you that were kind of in my channel or my live streams or the while, or if you're following me on Instagram, I did kind of open up back up or on Facebook. I did open up my pre-calculus course that I wanted to, because students had been asking me. I opened it up early in August, and then I closed the doors about 2 weeks ago. And that was to kind of get people, settled into my course as I began teaching inside the classroom. But that was a couple weeks ago before a lot of students actually had started actually school. And so I received a lot of emails of students, just kind of getting back into the, they might be watching YouTube for something completely different on the summer. And then they just started getting into the math videos and everything else. And they were kind of bummed that they did not have the opportunity to take a look into my pre-calculus course. So I just decided, I'm like, you know what, there might be some students that maybe are optimistic that they're going to do well in pre-calculus, or maybe they just weren't aware of I had a pre-calculus course by September once they started school. So I said, you know what, let's just, this is the first year that I'm opening up my course, and I didn't really know how it was going to go. And so I said, you know what, let's just do this one time. We realized that a lot of students don't start school in early August like you do in Florida. So I took my 2 weeks. I got started off with my class and with the students that had already enrolled in August. And I said, you know what, I feel comfortable just kind of opening back up for the rest of the month of September. And and then I'll close down doors again, and then I'll just teach for the rest of the year for on there. So if that is something that you are interested in, I'm not going to open it up in December. I'm not going to open it up in the spring. This will just be the final, kind of portion that I'm opening up my course. So if you are interested in it, all the details are on that link. I'm not going to spend time on this live stream for it. I might do another video or live stream on my YouTube channel, but I just recommend going to the link if you're interested. And you'll you get an email, and I have some videos already pre-made that you can go at that just explains the course and all of the resources that I have inside the course. So if that's something that's interested for you, go ahead and check it out. Otherwise, you can also email me at brian@freemathvideos.com with any kind of questions. The other thing I want to let you guys know is I am starting to finally get some new videos recorded. So it's kind of weird teaching a class with your mask on. So I have been making some additional geometry videos, and algebra 2 right now, we're still covering functions, which I have so many videos on functions. So I'm hoping once we kind of expand on some new videos in algebra 2, that I'll start recording some videos as well for you guys. So hopefully you guys will be able to see some new videos coming down the pipeline on my channel. I just want to kind of give you guys a heads up. Right now, I've just been kind of slowing down my uploads. As school kind of got back in a session, I just haven't had time to really create a lot of, videos. And then inside classroom, it's, it's just, I don't know, it's different. I have a mask on, all the kids they have masks on, they're behind shields. It's just a weird, different environment from on there. Are the link for the open course, I mean, it's just right here. It's brianmclogan.com/precalc. So that's where you can go ahead and check that out. At home for like tests and quizzes, how would you suggest students study pre-calc? Oh, well, do you have to pay for it? Yes, Catherine, it is a paid course. And the reason for the paid course is it's not my YouTube videos. So none of the videos that I have, well, actually not none of them. There are some videos that I have that I've posted on YouTube that are within the course. But all the videos that I'm making are designed specifically for my students inside the classroom. So my students that I'm teaching inside the classroom have exact same access to my course. This is really a course that I created 2 years ago for students as they're inside my classroom. And I mean, I don't want to go through everything on the course because that really wasn't my intent for this live stream. But yeah, I have a lot of like guided notes, all my tests and quizzes, which goes into the question of living, like, how would you study for pre-calc? Like I told my students just took their first quiz last week. They're taking their next quiz next week. And inside my course, I have last year's quiz, answers, video. I have the year before's answers, quiz, video. And I'm like, study, like look at the previous quizzes that I gave, like look at those answers, go over your homework. I think that's when you're studying for tests and quizzes, like go over past tests and quizzes. Obviously in my course, you have those. But take a look at the previous notes and practice problems. I told students, when you have my old tests and quizzes with the answers and videos, like cover up the answers and then try to do those problems on your own. And if you don't understand it, look at the answer, look at the video I have. So there's a lot of resources like that in addition to video lectures that I provide, but none of this stuff is available, on YouTube. That's why it's a private paid course. So just wanted to make sure you're clear with that. But again, you can just, check it out and see. I think even just for signing up, I do have not even sign up for the course, but even just going to the website and checking it out. I do have my summer assignment for pre-calculus to get you prepared for each chapter. That's absolutely free. So you can just go ahead and sign up and do that if that sounds good to you. Well, you are very welcome, Lucia. Your hand in there, sure. Addie, you're here. Good to have you in. Thank you so much. All right. Can you talk about limits at infinity? Maybe. We'll see. We'll see how far I can get. Do similar shapes. I don't know what shimmer. Say hi. All right. Guys, let's not spam in everything into the chat. All right. I'm doing functions right now. Well, yes, that's what we're doing right now. We're actually just finishing our functions test. And actually this Wednesday inside my course, I'm going to do a review, a live stream review. So that will be fun. Thank you so much. Yeah, Catherine, if you're struggling for a college pre-calc, I would definitely just reach out to me if you have any questions. Definitely my course is designed to support everybody that is, taking pre-calculus, but then also that, wants the support. I have all my videos. I do have a drip, and then I also have, I'm dripping my content. And then also I have all my previous resources. So all last year's tests, quizzes, exams, and notes and it's an overload of examples. So I think it definitely can be helpful for you if you're having trouble and kind of need that support. But it's definitely something that I also offer a 30-day money back guarantee to always take a look at it and see if it's the right fit for you guys. And yes, you can actually also go through my support on YouTube, which my members support, which is also bringing me into some new videos, which I look forward to actually joining in with you guys here rather soon as far as making some videos. So I do appreciate you guys notice that some of these videos that I have coming out, I do pay for a editor for them on those. And then also, I want to also let you know, because Addie is so awesome to let me know that about that membership. Some of you guys that responded to my email last week as far as providing some, what I hated most about, teaching. Well, I gave away free tutoring for that. And basically the reason why I gave away free tutoring for that is because my email or my YouTube supporters are basically sponsoring that free tutoring, so that is definitely something that I want to continue doing. Right now I'm doing it every month. But hey, if we are able to kind of build up the support and keep on going, I'm happy to keep on offering, finding a new student every week and doing a free tutoring session. I think that's a really, really cool thing to do. But Mark, no. Well, actually, yeah. Could I pay you? Yes. No, I'm just joking, Mark. No, you can't pay me. That's bad. But I don't know what math you're probably taking stats, right, Mark? I don't know. If you're taking stats, you could pay me as much money as you want to, and I still wouldn't remember your work. It would take me way too long. So, because I don't remember anything from stats. Ahmed, stop posting extra things. My question with quadratic inequalities. I'd measure quadratic equalities. I'm not going to go through the problem because I'm getting so many different lessons, but I would just say graph it and then try to find the values where it's going to be greater than or equal to 0. Actually not so much. Yeah, you can look at the graph. Might be the easiest one. Yeah, I just had to put some stats. Yes, no, Mark, nothing with stats. No. I remember P-score, Z-score, standard deviation, and that was about it. And I just remember it was a lot of reading, and that's where it kind of lost me from there. But yeah, haven't done any stats since I was in college, so wouldn't be much of a help for you. But you got Ren. You got him. All right. So let's go into the problems. So on the first equation, and again, this one, I wasn't really actually planning on doing this problem, but I wanted just to kind of take a look at it, and I wanted to kind of go through a couple of different ways that I looked at kind of solving this problem. And to be honest with you, I'm actually just going to be very forward. I haven't done a problem like this in a really, really long time, so I don't really recall the correct process. I just wanted kind of to go through. I looked at this problem and it kind of intrigued me. I was like, I don't remember doing these actually at all. So I just want to say, well, let me look at some things that I wanted to, kind of see about this graph, what would it, how would it kind of look? Okay, so, and actually x minus. Yeah. Okay. So there's a couple things I wanted you to show from there. The first thing is whenever I wanted to check this work, what I did was I subtracted y over x plus 1 to the other side. Okay. So then when I'm doing that, I got y is greater than, and then it was 1 over x minus 1 minus 1 over x plus 1. Okay. And what I did is I graphed that because I wanted to see what the answer was so I could like better understand what was going on. Okay. And I don't recall exactly what the graph looked like, but I believe there's a vertical asymptote here, vertical asymptote there, and the graph looks something like this. All right. So I think when you're going to be less than 0, or did I have that graph wrong? Let me see what I had back over there. X is minus the 0, y is greater than. X is greater than. Dang it. My explanation that I was going to give to you guys was not the case. So when y is greater than, it was x is less than 1, less than negative 1, x is greater than negative 1. But that doesn't satisfy what I was looking for. Now I'm confusing myself. Dang it. Well, the other thing I was going to show you guys what I did was I said x minus 1 had to be greater than 0. Or I'm sorry, that had to be less than 0. Because I just kind of thought about like integers. If I want to set the inequality, I know it can't be this. I know it can't be equal to, no, that had to been, you know what? I'm sorry. I'm actually maybe come back to this one. As I mentioned, I was in a rush and you know what? Sorry guys. This is why you stick to the problems that you know and you're familiar with, that you can go ahead and explain and not try to get out of your element. And I love this problem so much. I was like, oh, I think I can go and explain. But you know what? I'm just going to put a little check back to this because I actually need time to like understand my explanation to better explain it. If that makes any sense to you. I just can't, go through. I had something when I looked at this in mind. I was like, oh yeah, that's how I'm going to explain it and that's going to work. But then I just looked at the graph and now it's like, you know what? Why am I doing a live stream when I'm not fully, completely behind my explanation? This is not something that I have recently been doing. And every single time I try to do that, it always fails. It always backfires. But I do want to kind of look at this and as far as the, go for the explanation, and I might bring it back up to a live stream for you guys. But I'm sorry for wasting your time. Let's just go through another question from there. And again, I have no problem with this because it's something I told you guys I'm aware of. So I'll go ahead and hit each one of these just real quick to kind of go through you guys. And I know there's a lot of questions going up, guys, and I'll try to get a little tight on the time. I talked a lot about that zero-based grading. So this one says, find the slope of the line perpendicular to each line. We're actually doing this in our geometry class right now. So a couple things that I talked about with this is here's the old equation, y equals negative 3/2 x plus 5. And if we need to find the new equation, we need to figure out what the new slope is. So if it's going to be, find the slope of a line perpendicular to each line. Okay, so if it's going to be perpendicular, we know that's going to create a 90-degree angle. And the slope is going to be what we call the opposite reciprocal. So I'm not going to go into much explaining, but we can just go through. This is going to be opposite, meaning it's going to be the opposite sign, and the reciprocal, meaning it's going to be the flipped version. So that was question number 1. I don't know, right. Oh, that was going to actually write the equation, but let's go to number 3. Number 3 says, find the other endpoint of the line segment given the endpoint. Whew, that's a good problem. So the thing you need to understand is the midpoint formula. And the midpoint, x comma y, is basically going to give you the x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. If you have 2 points, like here and here, the midpoint is going to be the horizontal midpoint and the vertical midpoint. Oops. Right? So the vertical distance, the midpoint or the half distance of the half vertical distance and the half horizontal distance. And those are going to meet at what we call the midpoint, right? So basically all we're doing is to find that horizontal midpoint, we're going to add the two x coordinates and divide by 2. And then we're going to add the two vertical components and divide by 2 to find the vertical midpoint. So again, remember the midpoint is actually I should write it like this. I don't like right. The midpoint, which would be as xm, comma, ym. Okay, so that represents the midpoint point x and y. So what that means then is this horizontal component is equal to this. Well, we know what the midpoint is, so this is xm, ym, and then this is going to be one endpoint. So it's either x1 or y1, it doesn't really matter. Let's just call it x1 and this one y1. So therefore, now we can set up two equations by saying xm, which is negative 11, is equal to x1, which is negative 12, plus x2 divided by 2. And then the other xm, which is, or ym, which is 0, is equal to y1, which is 19, plus y2 divided by 2. And then it just comes into solving, so you're going to multiply 2 on both sides. So that'd be negative 22 equals negative 12 plus x2, because those 2's will divide out, so therefore you're just going to have your numerator. And then you'll add 12. Sorry, my penmanship's getting a little rough, and therefore that's going to equal a negative 10 equals x2. Over in this case, when you multiply everything by 2 on both sides, you get 0 equals 19 plus y2. That's not a y squared. That's supposed to be a subscript. So therefore, y2 is equal to 19. This one. The what was I going to explain? Oh, so yeah, that's going to be your other endpoint, which is negative 10, 19. All right, and write the standard form of the equation of the line through the given points. So in this case, we have 2 points. Okay, and if you guys have 2 points, then what we can do is use the point slope form, or you could use the slope intercept form. I think the easiest thing too, though, when you're given 2 points is go ahead and find x1, y1, x2, y2. To write the equation of the line, you need to find the slope. So remember that's going to be not x. It's going to be change in the y coordinates over the change in the x coordinates. So that'd be y2 minus y1 over x2 minus x1. And so let's see, what is that here? We have y2, so that's going to be 1 minus 5 all over a 0 minus 5. So that's going to be a positive 4/5, right? Because that's a negative over a negative. So m equals 4/5. And then we just need to use a point. And again, it doesn't matter what point you use. Typically, if we have to choose either, I think using x1, y1 is usually typical. But in this case, I have a 0 and a 1. I like 0 and a 1. So I'm going to use that. Okay. And we'll just call this x1 and this one y1. For point slope form, you can do y minus y1 equals m times x minus x1. All right, you might say, well, what happened to x2, y2? Well, sometimes you could use x2, y2 and for there, but again, to write the equation of a line, we want y and x to represent any x and y coordinate that lie on a line. So now I'm just going to plug in my values. Minus x1 is 0 equals a 4/5 times x minus x1, which is 0. No, where'd the 1 go? That's supposed to be a 1. Sorry about that. Okay, and then distribute, add 1, so y equals a 4/5 x plus 1. You are very welcome, Maurice. Your teaching is very efficient. Thank you so much, Maurice. I really appreciate that. That's why I'm saying this in case he sees, I do see Emma. I just went ahead and take a look, and I've been going through. Well, you're very welcome, Emma. I'm very happy that I could help you out. And so, Kathy, let's go ahead and take a look at, this last equation. So this next one is fractions, and I think most people could probably agree. Fractions is definitely something that most people still. Oh, why didn't I start using my red? Most people still need help. Even my pre-calculus and calculus students, they get stuck with fractions. So a couple things. Remember when you're adding and subtracting fractions that you got to get common denominators, right? So I'm just kind of keep things simple. And actually, you know what? I'll do one more. I got one more fraction in mind that I want to do. Dun, 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 dun. Dun, 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 dun. All right, so let's move this over. I made these problems up because she didn't give me any problems to do, but that's okay. Plus 3 over 8. Okay. So when you're finding common denominators, you got to find the LCD, which is the smallest number that both of your denominators evenly divide into, right? So you can list the multiples, but a lot of times to find a common denominator is just to multiply them, right? 4 times 3 is 12. Obviously, 4 divides into 12 and 3 divides into 12. So let's just stick with LCD as 12 in this case. So basically, the smallest number that the denominators are going to have in common is 12. So what do I need to multiply by 3 by to get to 12? Well, that's going to be a 4 over 4, and here a 3 over 3. Now again, whatever you multiply on the left side and the right side in the denominators, you have to multiply in the top and the bottom. Otherwise, you're not going to produce what we call an equivalent fraction. Right? Because what happens is, in this case, when you multiply, you get a 9/12. Well, 9/12 is equivalent to 3/4. And then we're going to add that to a 16/12. Okay? And again, these are equivalent up here, but now they have a common denominator. So since they have a common denominator, we can add the numerators and keep the denominator the same. So 9/16 or 9 plus 16 is going to be a 25 over 12. And then obviously you could reduce if you could, but in this case, we cannot. So we'll leave it as is. Now, the reason why I want to do this problem is, well, what about, here, what if you're just like, well, why not just always multiply them? And you can do that. Like, that's perfectly fine. But sometimes look ahead, what is the smallest number that 4 and 8 divide into? Yes, 32 they both divide into, but hopefully you can see here that their LCD is just 8, right? 4 divides into 8 and 8 divides into itself. So rather than multiplying both fractions, you can just multiply the left-hand side by 2 over 2. Therefore, you get a 6 over 8 plus 3 over 8. And that gives you a 9 over 8. Okay? Now, when you're dealing with fractions and a whole number, the best advice I can give you is just convert your whole number to a fraction. All right? And in this case, you can say, all right, so now I got to get common denominators. Well, again, what do 1 and 4 have in common? 4, right? So just multiply by 4 over 4 in this case. So therefore, you have 1/4 minus 12/4. And therefore, I'll give you a negative 11/4. And then over here, 1 minus 12, if you have $1 and you borrow $12, or if you borrow $12, you now owe me $11. I forgot, Kathy, you're in 5th grade. So I'm kind of teaching at a high school level of hey, remember this. And I'm like, oh, I should probably slow down. I apologize for that. In this example, I have 2/3 plus 5. And again, you can just do the same thing. Just put this over 1 and say, all right, what does 1 and 3 have in common? Well, that's going to be a 3, right? Well, 3 divides in 3 and 1 divides in 3. So now I have a 2/3 plus a 15/3. Again, you're going to keep the denominator same. 2 plus 15 is 17/3. And there you go. All right. And then, you guys kept on adding questions to me? You did. All right. So the next question was to study Algebra 2. Yeah, I'm going to go back up to that problem. Study Algebra 2. Okay. So anyway, so study Algebra 2. Again, guys, if you're going to study, here's what I think. You got to practice. It doesn't matter if it's studying or if it's differential equations. You're doing the same thing. You have to go ahead and practice going through the work. And I think you also have to be, curious, meaning what I mean by that is curious, to ask questions. Okay. So make sure you guys are putting in the practice. Make sure you're curious. You're asking questions. And there's one more that I used to always add into to there. And practice, curious. I'm trying to think if there's anything else. Not so much for studying, but I think maybe just asking questions like why things work. And that's what I was kind of going to, why you're doing what you're doing. That's what I was getting to the questions. But I think the curious ask questions. Oh, I think the other thing would be challenge yourself. Okay. So, yes, if you want to get good at the topic, I think one, you just got to practice the basic concepts, whatever homework you have, whatever you're assigned, practice, just practice that stuff over and over again. Don't just rely on whatever the assignment is. Like, just get extra practice. Make sure you're comfortable with that. I think the other thing is make sure you're curious, ask questions. Like, obviously, if you don't understand something, asking questions is like obvious, you need help. But my point was asking questions that are going to be curious. Like, why are we doing what we're doing? Why does this work? Why are these things connected? Be curious about the content, because that's going to help you connect what is going on in your class. And then the other thing is challenge yourself. You know, a lot of times when people feel like they understand something, then they get to the test and they're like, whoa, where'd this question come from? I've never seen this before. Like, how do I do this? You know, and those are types of questions that are really challenging. Do you really understand what you're doing? Do you really understand the concepts? And I don't think you're going to be prepared for those types of questions unless you're constantly challenging yourself, unless you're constantly putting yourself in an environment where you're like, all right, I now don't know what to do here, but so I have to rely on what it is I do know to be able to solve the equations. And that's difficult. A lot of students struggle with that. You know, that's definitely one thing that we do in pre-calculus. I give my students a lot of, basic problems. We'll focus on the basics and then we'll get to a test. And I'm like, all right, now let's go and see what you guys can apply. And it's difficult, right? I know exactly what they're dealing with. It's not so much that I'm avoiding, teaching some concepts, but I'm trying to have them apply what they know to different scenarios. And that helps you really kind of reach out and see what it is you know, what it is you don't know. All right, so functions and translations. The only thing I spend a whole day going over functions and translations. The only thing I want to do is just kind of give you a basic understanding of this though. A times f of b times x. Oops, no, don't do that. B times x minus c plus d. Okay, now again, there's a lot of different ways that we could write this. Okay, we could put some numbers in there like 2 times x. Sorry, let's do a 3x minus 4 quantity squared plus 5 or anything like that, right? Or it could be a square root function. I'm just going to do 2. So you could do 2 times a 3 times x minus 4 plus 5. Okay, so I want you to look at the characteristics though of these two graphs or of these two equations, okay? Because there's something that's very important going on. Please, David, no, I got rid of it. Dang it. Okay, so there's some things I want you guys to understand. Some changes. So when you're looking at transformations of functions, you need to understand inside versus outside. Okay, so what is going inside? Which numbers, which letters basically are inside the function? Which ones are outside the function? And hopefully you guys can recognize that the 2 and the 5 are outside, right? Those are outside of the function. It doesn't matter what the function is. It doesn't matter if it's square root, if it's quadratic, if it's cubic. It doesn't matter. A and D are outside, okay? And when you're dealing with outside, what that is telling us is that's going to be a vertical transformation, okay? When you have stuff that's inside, that means inside the parentheses, inside the function. Hopefully you can see here like the 3 and the 4 are inside, right? So they're inside the quantity being squared. In this case, they're inside or under the radical. Okay, so I want you to see the difference between inside and outside. And when you're dealing with something that's inside, that's going to be horizontal transformation. Now, what do I mean by transformation? Well, there's a couple different things that we could be doing, right? We could be reflecting. Okay, we could reflecting. We could shift. Why am I adding? We could shift. Or we could stretch and compress. Okay? So let's kind of go through when is it going to be a reflection. Well, it's going to be a reflection when it's multiplying by a number that's going to be less than 0. So any kind of number that's less than 0. So when you're multiplying, when you multiply by a number less than 0. So the only two numbers that are multiplying here is going to be my 2 and my 3. Right? Now, again, the value of 2 and 3 matters. And I don't want to go through all of the notes, but when, A is larger than 1, that's going to be a vertical stretch of 2. When B is larger than 1, that is a horizontal compression. It kind of gets confusing. You got to look at your notes, but I just wanted to explain why some of the things are what they are. Shifting is going to be from adding and subtracting. So you can see here, When you're adding inside the function that's horizontal, that's going to be shifting right 4. That's shift right 4. So anything C is going to be shifting to the right C. Outside the function is going to be shifting up and down. So this is up 5, or up 5 for the D. And if obviously it was negative, you'd be going down. And then the stretch and compression is going to be the multiplication times a number, or a lot of times we'll have a fraction. So I'll just kind of write, you could do like multiplication division, but really you're multiplying by A or 1 over A, or multiplying by B or 1 over B. Not really 1 over B, but I just want you to know that's like, here I'll say multiplying, I'm just gonna say like A is going to be either greater than 1, or let's see, A is going to be greater than 0, which is less than 1. And that's the same thing for B. B is going to be greater than 1. Sorry if I'm covering myself up. And then 0 is going to be less than or equal to B. Oops. B, which is less than 1. Okay. And so the reflecting, I should probably actually rewrite this now. It's a reflection when A is less than 0 or B is less than 0. So there's a quick little summary of why that kind of makes sense. All right, guys, last but not least, the last question I'm going to get to tonight is going to be the solving a difference of 2 cubes. And I do apologize, guys, if I'm not getting to your questions. I know a lot of you guys are adding into the chat, and I appreciate you guys joining in, but I'm just not going to be able to get to all of your questions. So what was I going to get to? Sum and difference 2 squared. So you need to know what the formula is. A cubed minus B cubed equals 0. And I don't really have my students memorize this, but there you go. Just because it's not something that really comes up a lot. But if you recognize you have a cube number minus another cube number, you can go ahead and follow this formula. So again, what we want to do is rewrite this then as a cube number minus another cube number. And we could rewrite 27 as 3 cubed. Okay, so therefore we can say, if you're going to follow the formula, you could say A equals X and B equals 3. So now just plug them into the formula. So we'd say, X minus 3 times X squared. Oops, it's my time now, it's all right. X squared plus 3 times X, right, your AB, that's going to be 3X, and then plus 9. Okay, now applying the 0 product property, you can have X minus 3 is equal to 0, so therefore X equals 3. And then over here, you're going to need to use the quadratic formula. So X equals opposite of B, right? X equals opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So X equals opposite of 3 plus or minus the square root of 3 squared minus 4 times A times C all over 2 times A. And the nice thing about knowing the difference of 2 cubes is that you're going to have, these are going to be your complex solutions. So 3 plus or minus, let's see, that's going to be a 9. 9 times 4 is 36, so it's going to be 9 minus a 36 divided by 2. X equals a negative 3 plus or minus, let's see, that's going to be a negative 27 divided by 2. And then you could simplify that square root if you wanted to use our complex numbers. So that'd be negative 3 plus or minus. Let's see, we could take the square root of 9, so that'd be a 3i. Square root of 3 divided by 2. Don't want to get into much more details, but the main important thing I want you guys to see is you have to do the difference of 2 cubes. Using the fundamental theorem of algebra, we know that there's going to be 3 zeros. So if you just use the, if you just try to add 27 over there, you're going to have a problem, right? Because x cubed equals 27, and if you took the cube root of both sides, that would only give you 1 0. You know by the fundamental theorem of algebra that there has to be 3 solutions. So that's why we'd want to use our factoring technique. Okay. All right, thank you so much. And Michael, I saw your question, guys. I am over my question limit. I do apologize for that. But I do have a fact in the Discord. You guys can obviously go and post questions still into the Discord. But thank you so much, Michael and Karen and Deza and Cheek and John. So same, opposite, all positive. Like John. Actually, you know what? I always never remembered those formulas. So I do appreciate that. I like that. Let's see. Amar, thank you. And Dor, awesome guys. -3. Good to have you guys on. Thank you so much. So, but that's going to edit or it for tonight. And actually, you know what? I want to go back to this problem because I want to redeem myself looking up to this. Because there was one thing I looked into this. Okay. Because I'm not sure on the graph. I got myself confused on the graph, but I just want to go through this and at least just kind of look through some numbers that I did. All right. So when I was going through this problem, I said, all right, x cannot equal 1. Because if x equals 1, that goes to 0, right? Because if you had, 1 over 1 minus 0. So you can't have that. And then I said, all right, well, what about if we had the this one? What would make this 0? And we'd say, well, x cannot also equal -1, right? Because when x equals -1, then we're going to be dealing with, and that's why I should have tried. I don't know why I didn't. Yeah. So here's the way that I look at this. So x equals -1, and that's not going to work as well. So it's trying to find the values. So we know there's two values that we can't have, -1 and +1, right? So these are two undefined values. So what I'm going to do is I'm just going to choose a value from each one of these, and just to make sure that they make sense, because all the other values work. So I just need to figure out, are they going to be true, false, or not true, right? So let's go ahead and plug in -2, 0, and then +2. Let's make things easy. So for -2, I have 1 over -2 minus 1 is less than 1 over -2 plus 1. All right, so 1 minus -2, or so -2 minus 2 is a -1/3. So that's 1, so it's a -1/3. And that's going to be less than, so 1 minus -1, which is -1. All right, so again, now what we're thinking is which one is going to be, less, which is less than as far as for that. And you can see that that one is going to be false. That is going to be greater than -1. So that is a false statement. Then let's go and look at 0. So 1 over 0 minus 1 is less than 1 over 0 plus 1. And so therefore we have -1 is less than 1. That is true. And then in this case, we have 2. So if you plug in at 2, you have 1 over 2 minus 1 is less than 1 over 2 plus 1. So therefore you have a 1 is less than 1/3, which is false. So therefore my answer is going to be from -1 has to be less than x, which is less than 1. So there you go. I do apologize for the person that submitted the video. I kind of got a little frustrated from the beginning, but hopefully at least the way that I approach that problem makes sense. And hopefully that is a correct one. Because again, it's not something I am as familiar with. I looked at the graphical portion, and then I think I just confused myself when I initially was doing it. And then when you have a live stream of like 50 people on the live stream all watching you, then you start to get a little anxiety. It's like when you're teaching class, which I've had many, many times. Like I'm teaching something and then I just can't think straight, So, but that's the joy of learning, guys. That's the joy in mathematics. You're going to make mistakes. You're going to get confused. And I'm not embarrassed of it by all. I want you guys to kind of have that, those feelings through me of that not understanding, of being confused, of like, wait a minute a second. And you know what? Doing what I did is exactly what I tell my students. You're confused, right? There's something you thought and you're like, something's not making sense. What I'm going to do is I'm just going to come back to it. I'm going to move on, continue on for the rest of my test, continue on for the rest of my quiz. And then I'll come back to that. And again, when I was like going through this, I was like, I can't remember, I don't know why I just started thinking, but I'm like, oh, just look at inequality. Like I looked at Desmos to kind of like look at the graph. Like, why don't I just go through an inequality and a number line and just think about it that way? So hopefully that was helpful for you guys. Why don't you give zeros? Oh, well, Tatum, you're going to have to go and take a look at the beginning of the live stream. I spent like 20 minutes talking about why I don't give zeros. But yeah, I am going to sign off, guys, for the rest of the night. Thank you so much for joining me on the live stream. And if you're wondering why I don't give zeros, the first 15 minutes of the live stream is dedicated to that topic. So otherwise, guys, have a great night. Again, if you are interested in me answering your questions for next week, go ahead and submit them into the description down below, and be more than happy to answer those questions for you guys next week. All right, guys, have a great night. I will see you guys next week.